All right, we're going to look at this graph right here. And it shows the velocity of a particle moving along the x-axis. So this is a velocity graph. We're going to justify our answers using information gleaned from the velocity graph, all right? So first thing they want to know is which way does the particle move first? So the movement of the particle is indicated by the sign of velocity. And at first here, my velocity is negative. And since it's moving along the x-axis, and the x-axis goes like this, it's moving left and right. So negative velocity means it's moving to the left. And the reason we know that is because the velocity graph is initially below the x-axis. Can't spell, this would help. X-axis, there we go. Okay? When does the particle stop? Well, the particle is stopped at any time where velocity would be zero, because it's not moving if it has zero velocity. And then velocity equals zero whenever the velocity graph is touching the x-axis. So that's going to be here, and here, and here. Technically, this is a zero, but since that's right at the beginning, we haven't really stopped because we haven't started yet. So the particle stops at t equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So at t equals 3, 6, and 10 is when the particle stops. How did we know that? The v graph, the velocity graph, is touching the x-axis. Notice I didn't say that the velocity graph crossed the x-axis because it didn't cross the x-axis here, nor did it cross it there. It's just that it's touching the x-axis. When does the particle change direction? Well, direction is indicated by the sign of velocity. So if it changes direction, velocity changes sign. So velocity is negative, negative, 0, negative, 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 0, positive. It goes from negative to positive at 6. So this happens at t equals 6. The velocity graph crosses the x-axis. Now we're supposed to graph the acceleration from 0 to 10. We're going to do that on this separate graph down here. So acceleration is going to be the derivative of velocity. So if I change this to, say, 75, I'm going to look at my velocity graph and look at its slope on the interval from 0 to 10. So my slope is negative 1 here. So my acceleration graph is going to be at negative 1. And it has a corner, so this guy has to have a hole. And then my slope is positive 1/2 for 2 units. And then my slope is negative 2 for a unit. And we got a nice happy step function. My slope is 0. So my slope is 0. My slope is 2. My slope is 2 again. So actually this should be filled in and continue all the way to here. My slope is 1/2 again for 2 units. And then my slope is negative 3. So there's my acceleration versus time graph. Now, when is the particle speeding up? Speeding up means that speed is increasing. So I'm actually going to jump down here because in H, I ask you to graph the particle speed. So if I'm going to graph speed, and speed is the absolute value of velocity, all speed does is it takes the velocity graph and reflects anything that's under the x-axis above the x-axis. So your speed graph is going to look like this. So the red is your speed graph. So when is the particle speeding up? It's speeding up whenever the speed graph is increasing. So that's going to be from 0 to 1, from 3 to 4, from 6 to 7 to 9. So from 6 to 9, I can actually say that whole thing. It doesn't have to be differentiable to be speeding up. So 0 to 1, 3 to 4, 6 to 9. So 0 to 1, 6 to 4, and nope, 6 to 4 does not make sense. 6 to 7, which was 6 to 9, 3 to 4. Sorry, I made a mistake. 0 to 1, sorry, 3 to 4. There we go. And 6 to 9. When is it slowing down? Well, it's slowing down when the speed graph is decreasing, which is going to be 2 to 3. And let's see, here it's flat, so that doesn't count. 5 to 6. And then 9 to 10. And when is the particle moving at a constant speed? Well, constant speed would mean when the speed graph is flat, and that's just here from 4 to 5. Okay. Now, we haven't justified any of these besides looking at the speed graph, and it says justify your answers using information gleaned from the velocity graph. So let's talk about the velocity graph and how it helped us get our speed graph. It's speeding up from 0 to 1, 3 to 4, and 6 to 9. Let's look at the velocity graph. 0 to 1, 3 to 4, 6 to 9. This is when the velocity graph is moving away from the x-axis. Moves away from x-axis. So if you're speeding up, your velocity graph is moving away from the x-axis. If you are slowing down, that's when velocity moves toward the x-axis. And anytime it's moving at a constant speed, this is when your velocity graph is horizontal. Okay. All right, moving on here. How am I doing with time? I'm doing okay. Particle moves along the x-axis so that its position is given by this function. Again, that's supposed to be a minus over here. X of t equals t cubed minus 12t plus 1, where x is measured in feet and t is measured in seconds. I want you to give this a shot before I do it and then just come back. There's not a lot of explaining that needs to go on here. So try this on your own and then come back. Hello, welcome back. So hopefully you've gone through everything, given it a shot. When we look at this next one here, find the displacement during the first 3 seconds. So displacement is just change of position over time. So our position changed from x of 3 to x of 0. So that's just going to be -7. Average velocity is displacement divided by time. So our displacement was -7, and 3 seconds have elapsed. So our average velocity is -7/3. Instantaneous velocity is the derivative. So I want the derivative evaluated at 3. So there's my derivative. 3 times 3 squared minus 12 is 15. Acceleration is just another derivative, so I took the second derivative. That says x double prime, not xn. So x double prime of t equals 6t. X double prime of 3 would then be 18. Now, when is the particle moving left? So to figure out when it's moving to the left, I need to know when velocity is negative. So what I did here is I took my x prime and said this needs to be less than 0. So I set my derivative equal to 0, got plus or minus 2. However, we're only concerned with when t is greater than 0. So I said then from 0 to 2, it's probably moving one direction. And then from 2 to infinity, it's probably moving in another direction, because at 2, the velocity equals 0. So from 0 to 2, I have numbers like 1. And if I plug 1 into this velocity equation right here, I get a negative. So it's moving left here. And if I plug a number like 3 into velocity here, I get a positive number. So v is greater than 0. Therefore, it's moving left on 0 to 2 only. Therefore, it must change direction at 2 because it moves left and then it moves right. So that is that. That is rectilinear motion all wrapped up. See you soon.